Hi, and welcome to the video on logarithm laws. Here we're asked two questions. So let's start by evaluating log base 6 of 3 plus log base 6 of 12. Because I'm asked to add two logs with the same base, I'm going to be using the product rule of logs. That is that when you have two logs that you're adding together with the same base, the answer will be the log of that same base, but we're multiplying the two arguments together. Let's have a look at what that looks like. We can write this as log base 6 of 3 times 12. This is log base 6 of 36. And in evaluating this, we ask ourselves, what power of 6 gives us 36? And the answer to that is 2. So the log base 6 of 3 plus the log base 6 of 12 is just going to be 2. The second part to these questions is a fairly typical question given in textbooks and exams. And that is they give you two estimations of logs with the same base, and then they ask you some similar common kinds of questions. So let's take a look at the first one. We're going to evaluate, using this information, log base 5 of 12. And we ask ourselves, how do the arguments given to us in the question, the 3 and the 4, relate to this particular argument here, the 12? Well, I know that 3 times 4 is 12, so I'm probably going to be using the product rule. That is, that I can write log base 5 of 12 as log base 5 of 3 times 4. Now I can separate these into two different logs, log base 5 of 3 plus log base 5 of 4. Now I have the estimations for these two logs, that is 0.68 plus 0.86, giving me a final answer of log base 5 of 12 equaling 1.54. Let's try the second one. We're going to try and evaluate log base 5 of 0.75, and we want to ask, how does the 3 and the 4 relate to 0.75? Well, I know that when I divide 3 by 4, I get 0.75 because it's 3/4. So I'm going to be using the division rule. So log base 5 of 0.75 can be written as log base 5 of 3/4. This is the same as log base 5 of 3 minus log base 5 of 4. We can now evaluate this. This is going to be 0.68 minus 0.86, which gives us a final answer of log base 5 of 0.75 equaling negative 0.18. Let's take a look at part 3. Log base 5 of 9. Now, in order to evaluate this, I have to see, how does the 3 and the 4 relate to this 9? Well, I know that 3 squared is 9, so I'm probably going to have to use the power rule for logs. That is that I can write log base 5 of 9 as log base 5 of 3 squared. This rule says that I can take that power, that 2, and bring it down into the front. So this is going to equal 2 lots of log base 5 of 3, which is 2 lots of 0.68, giving us log base 5 of 9 equaling 1.36. Okay, the final example, log base 5 of 20. We want to try and work this out and try and ask ourselves, how does the 3 and the 4 relate to this 20? Well, 3 doesn't go into 20, but I do know that 5 times 4 is 20. So I might be using the multiplication rule again. Let's take a look and see how that would work. Log base 5 of 20 is the same as log base 5 of 5 times 4. I can separate this into two logs of log base 5 5 plus log base 5 of 4. Now I have the second log, but I don't have the first. How do I evaluate log base 5 of 5? Well, I ask myself, what does this mean? It's asking me 5 to what power gives me 5? That's what log base 5 of 5 means. Well, 5 to the power of 1 will give me 5. So this means that log base 5 of 20 is going to be 1 plus 0.86, or 1.86. And that's how you use given estimations of logs for similar kinds of questions. Good luck applying the logarithm laws to future examples.